Hi, this video is about general probability formulas. The first formula that we should start off with is conditional probability. The formula for conditional probability says the probability that the event A occurs given that event B has already occurred is the probability that event A and B occur over the probability of event B occurring. Alright, now Bayes' theorem is basically similar to this, and it says the probability that event B occurs given that event A will occur is equal to the probability of event A and B occurring over the probability of event A occurring. Now this would also be equal to the probability of event A given B occurring times the probability of B occurring over the probability of event A occurring. So this is what Bayes' theorem is, and that's the conditional probability formula. Now let's move on. There's more formulas. There are two formulas that we use to test independent, or to see if the events are independent or not. The first formula is the probability of A given B is equal to the probability of A. If this is true, then the events A and B are independent. The other formula is the probability of events A and B occurring is equal to the probability of event A times the probability of event B occurring. If this is true, then the events are independent as well. So both of these test the independence of events. Now, something that goes along with this are mutually exclusive events. So on a Venn diagram, mutually exclusive events look like this. So event A, event B, and then the sample space. So here we have mutually exclusive events because there's no overlap at all. So if two events are mutually exclusive, then that means that they're not independent. Okay, the next formula is a general addition rule. This is a pretty important formula. It states that the probability of event A or event B occurring is equal to the probability of event A plus the probability of event B minus the probability of event A and B occurring. So let's visualize this on a Venn diagram. So we have our sample space here, and then we have one event and another event here, A and B. So if we take the so we want to find the probability of event A or B. So this sort of figure eight, sideways figure 8 here. So if we take the probability of event A occurring and we shade it in, and then we take the probability of event B occurring and shade it in the other direction, we get this area in the middle which has an overlap. And over here we can see that it's counted twice. So that's why we have to subtract it one time to get the total area and not overcount. So this is the general addition rule. Now in general probability we also have geometric probability and binomial probability. So in binomial probability the formula is P of x equaling n would be equal to n choose r times the probability to the r power times 1 minus the probability to the n minus r power. And let's here state what n and r are. So n, oh wait, this shouldn't be n. So here A is the number of successes. This should be A. And n is the sample size this should be A, and P is equal to the probability of a success. So this is the binomial probability. Here we have the probability of x equaling k, or x equaling a, so a certain number of successes is equal to n choose a times p to the a power times 1 minus p to the n minus a power. So the other probability is geometric probability. So this one states that the probability that y equals a is equal to 1 minus p to the a minus 1 power times p. So here a means something different. A is the first time we get a success. First success. And P is a probability of a success. So because this formula isn't on the formula sheet, it's pretty important to memorize. The easy way to solve this is you have A is the first time you get a success. So that means that all the times before that, or A minus 1 times, we have failures. So you have the probability of a failure, or 1 minus p, to the number of failures that we have, times the one time that we get a success, which is on the 8th try, and the letter 8th try. Today we learned about general probability rules. Thanks for watching this video.